This video is on modeling exponentials. I'm going to do some word problems that are multiple choice questions. A scientist begins an experiment with 800 bacteria cells. After each 10-hour period, only half the bacteria cells remain. Let T be the number of hours since the beginning of the experiment. Which equation could be used to represent the situation when only 200 bacteria cells remain? So if we look at all of our answer choices, we notice that 800, the 1/2, and the 200 are all in there. The differences are the factor, so we have 5/100ths of our factor, and then these are half for a factor. So only 1/2 the bacteria cells remain, meaning that we can actually eliminate A automatically, because we know we're going to have half of the bacteria, which is 5/10. Then we have to look at the exponent. It says every 10-hour period. That means every 10 hours we are going to be able to take half of it. So if it's only 1 hour, I'm not going to take half of it. So if I were thinking about how many times something happens, if I want to know how many times it will be cut in half in, let's say, 20 hours, every 10 hours it will be cut in half. So 20 hours would give us 2 times that it happens. Well, how did we do that? If we do 20 divided by our number of 10 hours, we get the 2 times. But this is the value that we're going to keep changing. So this would be our x. So if we look at our answer choices, we have 10 divided by our time, we have time divided by 10, or we have 10 times our time. This represents the same thing we just did up here, x divided by 10. So we would want to use however many hours we're focusing on, divided by 10-hour period to tell how many times it will be cut in half. So our answer is B, when we take our actual amount of hours divided by the 10-hour time period that we know of. On this next question underneath it, it says the value V of a car can be modeled by the function V of t equals 13,000 times 82/100 raised to the t, where t is the number of years since the car was purchased. To the nearest tenth of a percent, what is the yearly rate of depreciation? So we want to find the rate. What that means, we need to take our factor, because remember, this is our growth and decay factor, and we need to determine how far away that is from 100. So we take our factor of 82/100 and we turn this into a percentage, which is moving it to the right twice. So that's 82%. We determine how far away that is from 100, which is 18% away from 100%. So 18% is our rate of decay. So our answer is D, 18%, because it's a rate. We take our factor and determine how far away from 100% it is. Coming over to the question to the side, it says a chemist presented this graph to local government officials who needed to know the rate at which the trash decays inside a landfill. So we have the years, and we have the trash in tons. So that's 8,000 tons. Rate of decay of trash in landfill. Which is the correct interpretation of the rate of decay? So it says half of the trash will decay every year, every 2 years, every 3 years, or every 6 months. So if we start with 8,000, we need to know when half of the trash will still be there. So we want to know, when does it happen into 4,000? 8,000 to 4,000, and then 4,000, we want half of that to 2,000. So every year, this is counting by ones, these are counting by 2,000. So from 8,000 to 4,000, it took 1 year to get from 8,000 to 4,000. Then from 4,000 to 2,000, it took 1 year. So it's saying half of the trash will decay every year. So every year, we have half of the trash remaining. And we can look at that in a table format as well. The next questions, so a certain culture of 5,000 bacteria triples every 43 minutes. So again, it triples every 43 minutes, not every minute. Let B equal the number of bacteria T minutes after the start of the count. Which equation models the situation? A is a linear function. This is not tripling, so we know that one is incorrect. B is a quadratic. This is not tripling our values every time. D is adding values as well. This is not tripling anything. This is not an exponential function. The only one left is C. Now, if we look at that, we want to make sure we started with 5,000 and we're multiplying it by 3 each time. But it's however minutes we want to do, let's say 100 minutes. How many times does 43 minutes happen inside the 100? That will take our minutes and dividing it by 43. Just like on our first problem, we want to know how many times the 10-hour period happens inside of any amount of hours. So we divide. We want to know how many times 43 minutes happen in any amount of minutes. So we divide however many we have, divided by 43. And again, we can eliminate answer choices because they're not even exponential, because we're tripling it. Next one, a patient is given 100 milligram dosage of a drug that decays exponentially with a half-life of 6 hours. Which equation could be used to find the milligrams of drug remaining Y after any amount of hours we want to use? So we have to start with 100. So we have the 100, 100, 100, and 100. It's a half-life. So it's going to decay by a half. So this one is saying it's growing, which is incorrect. B is not an exponential equation at all, so that one's incorrect. C has a half inside of here, so we're going to say that that's potential. And D is not an exponential function again, so D is wrong. So 100 times a half, and we raise it to any amount of hours, divided by 6, because we want to know how many times does 6 happen in any amount of hours we want. This is the only one that fits. On January 1st, 2000, a car had a value of $15,000. Each year after that, the car's value will decrease by 20% of the previous year's values. Which expression represents the car's value on January 1st, 2003? So we started in 2000, we're going to 2003. That means that our X value will equal to 3 years because it's each year. Now it's 20%. We don't want to see percentages anywhere. So percentages is the rate. We need to change this into a factor. It's decreasing, so we need to turn this into a decimal. This is 0 and 2/10. But it's decay, so it's going to be B equals 1 minus the 2/10. So our B value is equal to 8/10. So if we look at our equations here, or expressions here, we know that we have 2/10 on C and 2/10 on D. Remember, the percentage is not the number that goes in. We never see the percentage inside the equation. We have to fix that. So after 3 years is what we want, not 4 years. 2003 is 3 years after 2000. So we want A. And the last one on here says, in 1984, the population of Greensboro, North Carolina was 197,910. According to the U.S. Census Bureau, Greensboro has been growing at the rate of 6 9/10% annually since 1984. So we have our starting value. What equation models the population of Greensboro, T, years after 1984? So again, we have 6 9/10%. We need to change that to a rate. A rate into a factor. So 6 9/10%. We need to move the decimal over twice to the left, which is equal to, add in a 0 to that space, 0.069. Since it is growing, we want our b value to be 1 plus the value here, 0.069. So if we look at our equations here, actually, we have the b value as written as 1 plus. So all of the starting values are the same. We are all being raised to the same exponent. We have 1 plus everything. So which one has 0.069? Not A, not B, not C, D has it. So the answer is